Contributors. In the field of science in the 15th century, Leonardo da Vinci, 1452 to 1519. Leonardo da Vinci is widely regarded as one of the most brilliant minds of the 15th century. Born in Vinci, Italy, he epitomized the Renaissance ideal of the polymath, excelling as a painter, engineer, anatomist, and inventor. Though he is best known for masterpieces like the Mona Lisa and The Last Supper, his contributions to science were equally remarkable. Leonardo meticulously studied human anatomy, creating detailed sketches of organs, muscles, and bones that were far ahead of his time. He dissected human corpses to understand their inner workings, paving the way for modern anatomy. Additionally, he investigated the flight of birds and sketched designs for flying machines, foreshadowing modern aeronautics. His mechanical inventions, including gears, pulleys, and hydraulic machines, laid the groundwork for engineering advancements. Despite many of his ideas being untested, they demonstrated a profound understanding of scientific principles in mechanics. Leonardo also studied optics, focusing on how light interacts with objects and the human eye. His observations about water flow and waves contributed to fluid dynamics, which later influenced hydrodynamic studies. Furthermore, he sketched early designs for war machines and armored vehicles, showcasing his innovative military engineering concepts. His fascination with nature's patterns led him to analyze plant growth and spirals, advancing botanical science. Leonardo's vast notebooks contain thousands of ideas and inventions, cementing his legacy as one of history's greatest visionaries. Nicolaus Copernicus, 1473 to 1543. Although Nicolaus Copernicus's groundbreaking work came to light in the 16th century, he began his astronomical studies in the 15th century. Born in Poland, Copernicus fundamentally changed our understanding of the universe by proposing the heliocentric model, where the sun, rather than the Earth, is at the center of the solar system. Copernicus's observations challenged the long-standing geocentric model supported by the Church and classical scholars. His ideas eventually led to the scientific revolution, sparking debates and inspiring further research into planetary motion. His work influenced future astronomers, including Galileo Galilei and Johannes Kepler, and redefined humanity's place in the cosmos. Copernicus was also skilled in mathematics and physics, using precise calculations to back his theories. He studied planetary orbits, providing mathematical explanations for retrograde motion that earlier models failed to address. In addition, he explored the relationship between astronomy and timekeeping, refining calendar systems. Copernicus's dedication to observation and empirical evidence established a foundation for modern scientific methodologies. His courage to defy conventional wisdom inspired generations of thinkers to question established doctrines and embrace rational inquiry. Johannes Gutenberg, circa 1400 to 1468. Johannes Gutenberg, a German inventor, revolutionized communication and information dissemination through the invention of the movable type printing press. Introduced in the mid-15th century, Gutenberg's press enabled the mass production of books, making knowledge more accessible and affordable. This invention played a critical role in the spread of scientific ideas by facilitating the publication of scholarly texts and research papers. Gutenberg's most famous work, the Gutenberg Bible, showcased the capabilities of his press and marked the beginning of the information age. His innovation democratized education and paved the way for the scientific advancements of later centuries. Gutenberg's press significantly reduced the time and cost required to produce books, encouraging literacy and intellectual exchange. It allowed scientists and scholars to share their findings more widely, accelerating discoveries. The replication of ancient texts preserved classical knowledge and revived interest in philosophy, mathematics, and astronomy. Gutenberg's method of printing influenced the Renaissance and Reformation by spreading revolutionary ideas. His legacy highlights the profound impact of technological advancements on cultural and scientific progress. Regiomontanus, 1436 to 1476. Johannes Müller, better known as Regiomontanus, was a German mathematician and astronomer who made significant contributions to trigonometry and celestial studies. He translated and expanded upon ancient Greek and Arabic works, preserving and advancing mathematical knowledge. Regiomontanus's work laid the foundation for modern trigonometry, which became essential for astronomy and navigation. His astronomical tables and ephemerides helped sailors navigate the seas more accurately, boosting exploration during the Age of Discovery. His influence extended to future astronomers, including Copernicus, who relied on his mathematical models. Regiomontanus also worked on refining astronomical instruments, improving their precision for observations. He established one of the first scientific publishing houses, ensuring broader access to mathematical and astronomical texts. His studies of planetary motion and eclipses contributed to more accurate celestial predictions. Regiomontanus emphasized the importance of empirical data, influencing the scientific method. His research connected ancient traditions with modern techniques, bridging gaps between past and future scientific developments. Luca Pacioli, 1447 to 1517. Luca Pacioli, an Italian mathematician, is often called the father of accounting for his contributions to financial mathematics. He published the book Summa de Arithmetica, which outlined the principles of double-entry bookkeeping, a system still used in modern accounting. Beyond finance, Pacioli collaborated with Leonardo da Vinci on mathematical and artistic studies, exploring geometric proportions and the golden ratio. His work in algebra and arithmetic provided a framework for future mathematicians and played a key role in advancing applied mathematics during the Renaissance. Pacioli's studies extended to chess, where he analyzed strategies and patterns, reflecting his logical mindset. He emphasized the importance of balance and symmetry in both mathematics and art. His writings introduced mathematical techniques to merchants and traders, improving commerce. Pacioli's teachings highlighted the relationship between theory and practice, fostering analytical thinking. His contributions helped shape modern business practices and mathematical problem-solving methods. Paracelsus, 1493 to 1541. While Paracelsus's most influential work occurred in the early 16th century, his early studies and training began in the 15th century. Born Theophrastus von Hohenheim, he revolutionized medicine and chemistry by advocating for empirical observation and experimentation. Paracelsus rejected traditional medical practices that relied heavily on superstition, instead emphasizing the use of minerals and chemicals to treat diseases. He's credited with founding toxicology and advancing pharmacology, pioneering the idea that the dose makes the poison. His groundbreaking approach to medicine transformed healthcare and influenced modern pharmaceutical sciences. Paracelsus also developed remedies for skin conditions and wounds, improving surgical treatments. He explored alchemy, linking it with medical applications and transforming its role in science. His insistence on practical experience over theoretical dogma redefined medical education. Paracelsus's holistic approach considered mental and spiritual health as integral to physical well-being. His contributions inspired later researchers to blend chemistry and medicine, shaping modern pharmacology. The 15th century marked a period of remarkable intellectual growth, setting the stage for the scientific revolution. These contributors, Leonardo da Vinci, Nicolaus Copernicus, Johannes Gutenberg, Regiomontanus, Luca Pacioli, and Paracelsus, challenged existing knowledge, embraced observation and experimentation, and laid the foundations for modern science. Their work not only expanded human understanding, but also paved the way for technological advancements that continue to shape our world today.